Hello friends, welcome back to the Eats a Guitar YouTube channel. We've got the 1963 AC10 with us again. We're actually hot off the heels of the part 2 of the series. Did a bunch of work to it, replaced all the non-carbon comp resistors with carbon comps, redid some of the filter caps, new 3-prong, redid some of the heaters, took out a couple of the plate resistors here on the power section, clean stuff. We found a very noisy resistor that was causing the vibrato channel to sound odd. Fix that. So now the amp's in a very good state. It's sounding really great, very healthy sounding. So we can finally move forward with the fun stuff I've been really looking forward to testing, namely the input wiring. So not to rehash everything, but the AC10 has very weird input wiring, 220K resistors instead of your typical 68Ks like you'll see on AC15s, AC30s, all Fender amps, so on and so forth. And there's no high and low inputs, they're both the same. So what is this going to sound like if we convert it over to more like the AC15 wiring, for example? Excited for that. The internet's pretty split, so we'll have to see for ourselves and kind of have a definitive video maybe for that. Other thing is the 100 ohm plate resistors on the AC10s. Those kind of pad them down a little bit, so they're not really making as much power as they could be. You know, you'd think they're very similar to the early AC15s. Why is it only 10 watts? Is it only 10 watts? We'll do that test and see what that does. And yeah, that's kind of the main thing. And before we get to that, though, I want to go ahead and test the owner's new EF86. He just had shipped to me. He bought a new old stock that just arrived. So we'll grab that and just make sure it's good to go before moving forward. We've been using my Mullard that came with my Vox AC10, my 64, which is a known good tube. So we'll confirm his new one is good, and then we'll do those tests. So we'll just do a quick test. I've got the cabinet lifted up so the mic can pick it up. We'll turn it on, hear the sound with this, make sure this one is roughly the same, you know, not too noisy, not too microphonic, and we'll just check with the vibrato channel dimed. So let's give it a shot. And I'll bump up the gain on the mic so you guys can hear it a bit better in case it's not very loud. We're blowing out my camera. We're blowing out my mic. I had to turn the gain way down. You can probably barely hear my voice over it. Turn the gain way down so you can hear the microphonics. Yeah, that's unfortunate. This otherwise very, very nice tube is just unusable. You heard how much quieter this one was. You probably could barely even hear it on, even though it's dimed. And obviously we fixed the issue we were having. And then, yeah, microphonics. So hopefully the owner can get that swapped. I put the Mullard EF86 back in so that we can do our testing and move forward. The multimeter is hooked up to the output jack here, as well as my oscilloscope, which is just off camera. So this is going to be measuring the AC volts. We're going to check the wattage this thing is putting out, the clean watts. Very curious because we do not have the 100 ohm resistors that were factory in this hooked up anymore. So in theory, it should be less padded down, and hopefully we'll get a bit more than 10 watts clean. You know, we'll see how close we get to 15. So let me go ahead and just turn on the signal generator, and let's start seeing some numbers here. We're in the vibrato channel right now. Okay, so we're starting to see some AC volts. I'm gonna grab my phone so you guys can see the oscilloscope. I'll pop that in. So I've got it set up with 400 hertz signal going into it right now. Go ahead and turn up the amp. We're looking for the waveform. Once it starts cutting off, need to get a bit more signal out of the signal generator. So there it's starting to clip a little bit, if you see that. Right right there at the bottom. So that looks about max. So maxed out without clipping, we're getting about 9.8 AC volts there. So we do the math. We go 9.8 times 9.8, divide that by the 8 ohm load. So we're putting out basically exactly 12 watts right now. So we're not getting 15 watts by any means, but we're also getting more than 10. I don't know if the 100 ohm resistor, if that's really bringing it down 2 watts or not. A lot of amps actually achieve more than what their max wattage is supposed to be. This is biased a bit cool too, about 84% with the power tubes the owner provided. So perhaps there's some more room we could get out of it, a little bit more wattage, but I'm pretty happy with that. That tells me it's very healthy. So we'll go ahead and turn it back down. Got the plate resistors reinstalled. Those are 100 ohm coming off of the pin 7, which is the anode of the EL84. And that's going from pin 7 through 100 ohm resistor to the output transformer. That is not typical. You don't see that on pretty much any other amp I'm really aware of. So very curious to see if that does anything to the output. So everything else is the same. Signal generator is the same. The amp was maxed out on the volume for the vibrato channel to get the most clean output out of it. The signal running into it is not that hot. And yeah, let's see if it puts out more than, what was it, 9.7, 9.8 AC volts. So let's see what happens here. So now the amp is putting out 9.4 volts AC roughly. So that gives us 11 watts. So basically we lost essentially 1 watt by putting the 100 ohm plate resistors there. So it is bringing it down a little bit, not a ton, but I mean 1 watt is not nothing. So that's kind of interesting. I think we can go ahead and move past this, though I do want to, we're going to remove the 100 ohm resistors, but I do want to throw in a bit of a hotter bias and see what happens. So it's got the stock 130 ohm resistor in it right now. I think it was like 83% plate dissipation with the tubes provided by the owner. Let's see what happens with 100 ohm, see if that warms it up when we get closer to that 15 watts. So we're at 12 watts max without those resistors. Let's see what happens. 100 ohm bias resistor temped in. Let's check the bias. The resistor itself measured 98.4. So let's just go ahead and turn everything down here. No signal into it. Turn it on. So plate to cathode voltage is right about 286. And then the voltage across the resistor, that's warmed up about 8.6. This gives us 98%, so just about right on the money actually. So we might consider swapping that over. And let's see what kind of wattage it puts out now. See if that makes any difference. And we did remove the 100 ohm resistors as well. So plug this back in. Okay, so we've crossed 10. So just about not clipping there. So let's say we've got 10 times 10 divided by 8, 12.5. So we gained another half a watt, basically, just doing that bias swap. So that's pretty good. So we get about 12.5 watts out of it. That's not bad at all, and definitely what I would consider healthy. Only problem with the 100 ohm resistor, I hate using these kind of cement style ones, whatever you call it. I like using these, but just so gigantic, doesn't really fit in these areas. I'll see if I can get this to fit, and we'll swap it over to 100 ohm, just because that's much better bias, 98%. It's basically right on the money. Well, I am super curious to hear what you guys have to say about the comparison there. I'm also curious for myself how it sounded in the recording. For me, there was some pretty clear differences, but it's hard to keep track of it all because there's, time gaps between each excerpt I did when I was soldering in the components or changing things. So I'm going to have to really listen just like you guys after I've edited it together to get a full picture of what was going on. I will say just real quick from my perspective, it seemed like adding in the 100K resistors in parallel did make a difference. Not a huge difference, but it did seem like it had more gain and more top end. I even tried alligator clipping them on and off camera just to see while the loop was going if I could hear anything. There was very clearly a difference that was audible. It just the difference wasn't super massive. So I'm curious in the recording if it comes across more or less. And then doing the change where we kind of removed the connection of the switch tip to ground on one side to give you the high and the low inputs. That was a huge jump in gain for the high input. And the low input came across to me like it was basically sounding, more or less how the amp sounded stock with the 100K resistors in parallel with the 220Ks. So to me, that was pretty obviously the best of both worlds. So we're going to stick to that. I'm going to clean all this up and do it more properly, but very, very happy with that overall. And I'm excited to play with that a bit more on my personal amp. Now, also off camera, I did some more work. You'll see here, I removed the stock 130 ohm resistor, and that was to bias a bit hotter. I mentioned that before. This got us right about 94% or whatever it was. So that's good. And then I also replaced the bias cap. It was a 50 microfarad, 50 volt. There's only 9 volts across here. So I put in a new replacement. The Sprague that was in there was a replacement, fine. In theory, the install was just really crappy. So I just wanted to be a bit better and know it'll be good to go for an extremely long time. So took care of that. And then you'll notice, so the original 130 ohm resistor went through here to ground and also connected here to the filter cap. I removed that whole thing, and then I gave the filter cap its own separate ground connection over here with the little tag strip. There's a lock washer under there. So yeah, just to give it kind of its own ground a little bit, see if that would help with a little bit of the hum. And it did not, but there's nothing wrong with doing that. There's only real net positives. So all that is looking good, but the reason I have the amp like this more is actually because I want to add in screen resistors. So we're going to go ahead and move forward. I was trying to debate what I want to do. Do I want to do larger values, or what do I want to do? I want to go kind of off the vintage AMI values for the AC30, for example. And I'm going to do 1K, I believe I have Vishay power metal films. So we're going to move forward with 1K screen resistors, which is not factory. They did not have those on these amps, but we're going to go ahead and add them in. So with that, let's move forward. Zooming in a little bit, we have the screen, which is pin 9 of an EL84. And so this one, you'll see that they are connected with this red wire. And then that's going here to the filter caps, is the screen supply. Now, we want to add in resistors, but we want to add in a resistor for each. So where do we tie it in, right? There's not an open space available, but looking here, we added this jumper wire because this originally was a 100 ohm resistor. All we can do is just remove this wire, have the yellow connections go straight to the tubes, and then that leaves us with 2 open junctions for the screen resistors to go, and then for this wire to connect there. So let's go ahead and move forward with that. Awesome, that looks very good. So we redid all the connections here. We got the screen feed coming to this tag. We removed the plate connection that was going there, just went directly to the tube socket here. Retained this one as I had it before, since this is going to be a very long wire. If it only needs to go to here, and I don't want to cut an original wire short, so rather just leave that alone. We only needed one tag to do it, so freed up this tag, and yeah, that should be good to go. So now we're done with this entire section of the board. We can kind of just cross this off our mind and put the slider board on and just kind of not worry about it for a very long time. So next we'll go ahead and tackle the input wiring, get that cleaned up and nice, and then we'll do the speaker jack wiring, and then we should be good. Fantastic. There you go. So you got 100Ks paralleling all of the 220Ks, and then the switch tip connections here are disconnected on the top, making these the low inputs, and a bus wire for all of the ground on the back, since that was missing a portion. And then the bottom is stock other than the parallel resistors. So these two furthest from the camera down here are going to be the high inputs, and these will be the low inputs. I thought this would be kind of an interesting test just to confirm and show the high and low inputs. So I've got a signal generator. The amp is not plugged in. There's no tubes in it, nothing, but I've got the signal generator producing a 1 kilohertz sine wave, and it's very, very loud. And so I can measure the AC volts with my multimeter here. So I'll try and get out of the reflection for you guys. So this is touching the tip of the plug directly. So it's about 8.2 volts AC coming out of it. Now we're in the low input right now. So this is, the source is 8.2 volts. And if we go here to where it goes to the grid, it drops down to about 4 volts AC. And I can even go ahead and touch the pin directly and show that it's, it's getting right there. So it's getting about 4 volts to the tube. Now, if I go ahead and switch, and I'll show real quick why that is. So the signal is coming in through here. So this is your full 8.2 volts. And then it's going through this parallel set of resistors. And then part of the signal is going to the grid wire, which is going to the input of the tube here. And the other part is going through the other pair of resistors. And it's these two connections right here are connected when there's a plug not in it, right? So on the top here, this one's disconnected because the plug is in this jack. So only this one is active. Now on the bottom, imagine both of these are active. So the signal is coming through the 2 resistors. So part of the signal is going to the grid. The other part is being bled to ground because it's going through this. And then on the bottom jacks, there's a bus wire from here to here. And the top is ground. There's a bus wire for ground on the top here. So it's basically just getting bled to ground. So that's why you go from, 8.2 volts AC in this case to 3.9 volts AC. Conversely, for the bottom jack, I'll show the tip. This is the high input. So again, we're getting 8.2 roughly volts AC. Now look at this. Now we're getting about 7.6. So we went from 4 to 7.6. So basically double. Quite a big jump. Again, I could show on the pin itself. So there you go. Input wiring all done. We'll confirm the normal channel real quick, and then we'll get to the junction box. So let's talk game plan here for the junction box. I'm going to be using this Hammond ABS plastic project box model 1591. This is going to be mounted on the slider board using the chassis bolt here that holds the slider board and the chassis together. So it's going to be basically sitting more or less like this, just with the slider board between here in place. So we'll be drilling a hole through here so that can be attached that way. And then we are going to be using the 3-prong cable that this amp came in with. Might as well reuse it because it's got 3 conductors in there, and we need 3. So we have the 8 ohm, the 16 ohm, and the ground. So we'll have those 3 hooked up to this, and then that'll be run into here. And then we'll have 2 jacks, switchcraft jacks installed on either side. One will be 8 ohm, one will be 16 ohm. And then the speakers, the owner is providing himself, and he's going to be doing that work himself. He's going to install a plug on the end so that it'll plug, so the speakers will plug into the junction box here. And then you can also run the speakers with a different amp or run this into a different set of cabs. So that gives you maximum flexibility. It's exactly what I did on mine. So that's the plan. I've decided to do kind of a little pseudo strain relief here. I am using the 3-prong cut for the cables like we already mentioned, and I've got the ground connection just going directly here. I'm bypassing this because there's only 2 sets of terminals here, and I need 3. So one's going to have to be heat shrunk and connected directly to the 3-prong cable here, or the 3-conductor cable anyways. So I might as well bypass this, which this could be a failure point, and just do a solid soldered and hooked connection and then not have to worry about any of them. So I've got that connected here, and then I used a zip tie through this top section of the terminal and then zip tied to that. This one on here, so it's really tight. So I could pull this extremely hard and that is not coming undone. So that just kind of gives us some extra protection just in case something were to happen. And if you can see here, I'll zoom in even more. You can see there I've got the 2 leads like this where they're hooked together, and I'm going to go ahead and solder, and then we'll heat shrink those and we should be good to go. So now we've got a mechanical connection as well as a solder connection. Now that we've got the 8 ohm and 16 ohm taps connected, we just got to keep in mind that green is the 16 ohm and white is the 8 ohm. Obviously black is ground. I say obviously, you know, with a typical 3-prong, green is ground, but we're treating this as just a 3-conductor wire. So now what we can do is just go ahead and get the slider board, connect this to the slider board, see how long we need this to be, probably fairly short actually, something along these lines, and start working on drilling this. So this is what it looks like when it's all done. We've got the chassis bolt here. We've got both jacks. We've got white wire going to the tip. So this would be the 8 ohm, green wire going to the tip. This would be the 16 ohm. And then we've got the ground, and that is jumpered between them. You guys better look here. And then just a little pseudo strain relief with the zip tie there, just for extra security. And yeah, and it's nice and flush. So you won't actually even be able to see this once the backboard is on because it'll be covering this. So super incognito. I did the same thing to my AC10 and it works great. And this should give the owner tons of options. So with that, we're done. Just got to put it back together. The owner's got to do some work with speakers. And then I think once he's done that, in the future, we'll do another video, perhaps after I finish working on mine, so that we can compare the AC10s and maybe just do kind of a fun little deep dive into some vintage Voxes. So there you guys go. I hope you guys enjoyed this video and the series in general. Let me know what you think in the comments below, and give the video a thumbs up if you liked it. Subscribe for more. Till next time, see you guys.